Hello, I'm Tanya Bhomit. I'm currently a final year student on MSc Chemistry, IIT Dhanbad. I have gained significant experience and expertise in organic chemistry, and I'm on my way to hone my skills and experience on this genre. So today I'm going to teach carbonyl compounds preparation. So I will make it short and crisp. So first starting with my bioxidation of alcohols. So from alcohols to aldehydes, we are going to use PCC, pyridium chlorochromate. So alcohols, it is converted to aldehydes. Now, if the compound is this, it will be converted to aldehyde. If the compound is at 2-degree alcohol, it was a 1-degree alcohol, it's a 2-degree alcohol, then it will be converted to ketone. An advantage of using PCC or Jones reagent is that it will not be further converted to carboxylic acid. For example, if we use KMnO4, then if in a question it is given KMnO4, then it will directly be converted to carboxylic acid. Now from dehydrogenation of alcohols, again we use the same substrate, and here only the reaction conditions will be changed. We use copper or Ag, silver at 300 degrees Celsius, and it will give the same product, ketone. Similarly, here using 1-degree alcohol, PCC or copper, silver at 300 degrees Celsius, it will give aldehyde. But if we use 3-degree alcohol, the product that we will be getting, because there is no alpha hydrogen attached to the carbon to which OH is attached, it will form an alkene by elimination mechanism. So now third is by ozonolysis of alkene. So in ozonolysis, we use O3, ozone. So if we take an alkene, for example, this, then it will form an intermediate like this, which will go over a rearrangement and will give ketones. Now it can be changed according to the substituents present attached to the alkene. If there are hydrogen, it will form aldehyde. If there is a carbon groups, R groups that have carbon, then this will be converted to aldehydes. Now O3, if the condition is given Me2S, then it will be a reductive ozonolysis. It will form ketones or carbonyl compounds, ketones or aldehydes. If O3 in presence of any oxidizing agent is given, or OH2O, then we will get carboxylic acid. That means this, after forming this intermediate, this carbonyl compound, it will again be converted to carboxylic acid only when there will be an H present as such. Now moving on to one more thing for ozonolysis. If there are two double bonds present, only the electron rich double bond will be broken. For example, there are two double bonds like now see, this bond has no electron withdrawing group, but this group has one electron withdrawing group, ester. So this will pull electron towards itself by resonance. So this alkene is more electron rich as compared to this. So this bond will be broken and it will give now for by hydration of alkynes. I'm writing it here. So alkynes, the reagent used is this. So first an intermediate is formed, that is this is an intermediate. Now H2O is present. This will attack at this center. One more thing, H2O will attack at the more substituted position. For example, if there would have been a group, for example, RC triple bond H, then this H2O will attack at these positions compared to this position because this is more substituted. So the ring will open in this way and we will get an intermediate like this. This will form. Now this is called enol. So therefore it will undergo keto enol tautomerism and will form this product. This is a ketone. So this reagent Hd2SO4 will produce ketones. Now moving on to 5. This is from acyl chloride. Acyl chloride is very reactive compound. This is called acyl chloride. So here we will make it undergo Rosenmund reduction reaction where the reagent that it includes is hydrogen, palladium and barium sulfate. And it will be converted to RCHO directly. It's a very important term reaction. 6 is from nitriles. Now dibel. Dibel is diisobutyl aluminum hydride. The structure is this is the structure. Dibel is a good reducing agent. Is a mild reducing agent. It will convert. It is mostly used, intentionally used to convert cyanide groups or any groups to aldehydes. It will also convert ester to aldehyde. If these such groups are not present where you can incorporate CO bond or carbonyl group, then and dibel H is given, then you undergo reduction of that particular substrate that is mentioned, and the reaction condition, the reagent that is mentioned is dibel H. From nitriles we can also get CH2 using Grignard reagent. The mechanism is RC triple bond and This will go hydrolysis and will form ketone. So this will give you aldehyde, and from the same substrate with Grignard reagent we will form ketone. Then moving to from esters. So I have explained how we will get aldehyde or ketone from ester by oxidation of methyl benzene. Or we can say toluene. We will use mild oxidizing agent. So using this, we will get this. But any oxidizing agent won't make this. This will be formed as intermediate and we will get carboxylic acid. For example, if we use KMnO4, which is a very strong oxidizing agent, we will get this. 9. From benzene. From benzene, using Friedel-Crafts acylation. Friedel-Crafts acylation, where benzene is very unreactive to electrophilic substitution reactions because it doesn't want its aromaticity to be broken, to be dispersed, to be disturbed. Therefore, we need an activating agent, that is a Lewis agent, AlCl3. Now, and we will use an acyl chloride, for example CH3COCl. Now what happens is that first, AlCl3 is a Lewis acid. It has an empty p orbital, and therefore the Cl here of the acyl chloride will attack at the aluminum's p orbital, empty p orbital, and will form this form. Now there is an activating agent. This electrophile is created, CH3CO+. This is an active species electrophile. I am representing it as E+. Now it will go and attack benzene. So here we get a carbonyl compound. And from Gatermont-Koch reaction, from benzene we use CO plus HCl and we get an aldehyde. So here we form a carbonyl compound that has this aldehyde, and from this we form a carbonyl compound attached to benzene ring. It is a ketone. So thank you. That was a short, crisp notes, a brief elaboration of preparation of carbonyl compounds. Thank you. Hope you have enjoyed the lecture.